All right, how's everybody doing post coffee break? Woo! Excellent. Welcome. All right, so our next speaker is going to be Sarah Treadwell, and she is going to be talking about searching for the origins of life 2, the Lost City Hydrothermal Field Strikes Back.
Hello. So if you saw my presentation last year, this is just building on what I presented on last year. However, last year I learned that everyone was really excited and interested about the vent fields themselves. So we're going to talk a little bit about who I am and the vent fields, and then we'll tack on a little planetarium stuff right at the very end. So here we go. I also just wanted to make it Star Wars themed, so I did. So who am I? I am Sarah. I go by Space Case Sarah. I am actually a science communicator whose interest is primarily in astrobiology, but this has gotten me all around the world doing lots of just amazing and different roles. So I got to go to ALMA this year, which was really neat. And my work has been in astronomy. I've done sidewalk astronomy. I had a radio show for a while. I am a frequent commentator on CNN. I just am like the jack of all trades. So I go scuba dive, I've been to Everest Space Camp, I've done Mars analogs. So like, how did she end up on a ship? So I was contracted by the United States Science Support Program to be an onboard communicator for Expedition 399 with the International Ocean Discovery Project. They were looking for someone who was connected to NASA astrobiology because we were going to go to an event field that's very interesting for astrobiology research. So I'm not a geologist person, but because of that connection, that's how I got contracted to sail on this and live on this for 2 months. And it like truly was the most life-changing experience that I've ever had. I always say there is BS and AS, before ship and after ship. Like there was this career that I was building, and then this just completely turned me in a new direction. So we're going to do a crash course science class right now on the Lost City hydrothermal field and why is it so important to astrobiology science. The Lost City is located on the Atlantis Massif, so you see this big crack that's going right through the middle of the Atlantic Ocean. The crack is there because this is where two plates are splitting apart really, really slowly. So the mantle rock is actually rising up in this spot and making these vast mountain ranges under the water. Thank you, Marie Tharp, for proving that. And because of this, it's a really interesting place to also go core drill into the ocean floor because you can access those mantle rocks. So there's a huge interest to get to these spots because you can actually get to the mantle. It is not the moho proper. If you're familiar with the moho, that is supposed to be the line where the crust turns into the mantle. This is not the moho proper, but you can get to these mantle rocks that have not been altered by wind and weather and rain, and it's a really interesting geological place to be. So we went there to core drill, and core drill very close to these vents. So what is happening, and how are these here? The mantle rock that I mentioned that is getting close to the surface of the crust has a mineral in the mantle called olivine. And olivine, when it makes contact with seawater, has a very strong chemical reaction. And so there's a few things that are happening. One of those things, and this process is called serpentinization. One of these processes is calcium carbonate byproduct. So that's what these spires are like, basically like the calcium on your faucet kind of building up over time. And these take millions of years to build up this big. They are producing that. These vents are also producing an exothermic reaction, so they're giving off heat. So if you can see on this is called the IMAX flange, you can see the heat rising off of it. It's giving heat, which is really cozy for bacterial life. And then it's also spontaneously producing hydrocarbons, so stuff like methane and hydrogen. And a lot of scientists think that, there's kind of a couple of theories of how life got started on Earth. But this is a very leading theory that a place like this, not this one, but somewhere like this, maybe would have been a location where life got started on Earth. And what's so cool about it is that, unlike all the other hydrothermal fields that we know of, this doesn't need the heat of the Earth's core to make this heat and this chemical reaction. It's happening from that chemical reaction with the olivine in the mantle rock. So it's super, super exciting, super interesting. So we went there, like I said, not to just only access that mantle rock. We also had a special tool that we sent down, and I don't have a really great picture of it, but it's this, that we sent down to take fluid samples. So we went to a hole that was previously drilled, sent this tool down that had different bottles inside that had shape memory alloys built into it. So when it hit the right temperature, it would spring open and take a sample, and then it could take multiple water samples going down the hole. And the goal was to see how far down were we going to find life. And what's actually really exciting is the biologists have just been releasing their findings, and they're like, wow, it is like way down there. So they're super, super excited how much life they found. But we, for some reason where we were, it was extremely easy for us to pull up this mantle rock. The ship previously had pulled up 97 meters of mantle rock in this location with about a 40% recovery rate. So of that 97 meters, only about 40% of the rocks made it back up to the surface. We ended up pulling up 1,268 meters with almost a 100% recovery rate. So this was so exciting and so important, we got published in Science this last year. So I'm very proud of that because my name is Dead Last, but I'm on it. So anyway, I leave this, this expedition. Oh, sorry, and then why is this important for space science? We know that Europa, and that's what's pictured here, and Enceladus have these, icy icy crusts. We know there is salty water underneath that, and we know that their cores have olivine. So if these chemical reactions are happening on our ocean floor, what is happening out on those ocean floors? So this is, Europa's water coming out there, and then this is a model that someone made from NASA saying, like, well, maybe there are these white smoker vents down on Enceladus. And if we think that that's how life got started on Earth, what could possibly be out there? So that's why it's a really, really unique spot to go look at life and the limits of life on Earth. So how did this end up in a planetarium? I was in a meeting with NASA Astrobiology Science Guild like 3 days after I got home, and Open Space happened to be presenting, and they were like, we have, astrobiology stuff that you can present in your talks, but we don't have anything that goes under the water to vents. They actually said that before I could ask, and I was like, oh, that stinks, because that was pretty important for me. And then someone from the NASA Scope grant program popped in my chats and said, hey, you could write a grant, and you could work with Open Space and throw that in. So this is what you got to hear me talk about last year, and I was like, okay, not knowing what I was doing, and won the grant, and that kind of just set me on this really wild adventure of trying to build an underwater world in a planetarium dome. And it is much, 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 much more difficult than I expected. This was pretty easy. The ship was simple to put in. But what was really challenging was these vents. So these came from California Academy of Sciences. They had built some of these vents for the Living World show. And they were like free floating, and they were hollow in the back. And it was just like, I didn't know how to make this make sense. And we tried so many different things, and what we ended up doing was we threw in a model of the Alvin to give you something to kind of get a sense of something. And then one of the developers found this 360 video of, it's actually a ship diving, like a shipwreck. And it we gave some depth, and so like my strategy was I would just fly up to these vents really close, maybe focus on the Alvin, and you wouldn't really know that you were actually, there's scuba divers in the 360 bubble. So I presented on this last year, kind of had this resounding theme of like, man, I wish I could have done better. And that's when the vent field strikes back. So I was just saying this story to the right people and the right ears heard, and NASA Scope decided to put out super jumbo grants, and they were geared for educational and outreach opportunities, and I won the full jumbo grant. I know. And so this allowed me to contract a VR developer to make an ocean floor and actually make it make sense, which has been so cool. And I am really excited to share with you, this is like the first time anyone has seen this publicly, well, maybe 2 people privately, what this underwater world is looking like so far. It's not done, it's not perfect, but it gives you such a better sense of this mountain range and the vastness of the ocean floor. So we're gonna go down, and I wanna point out really quick as we go down, it's kind of dim, maybe I can point it out quick. So this is just the tiny little sliver of mountains that we were able to map. But as we get down, you'll see the Alvin. Maybe you can. Hold on. No, I don't think it's bright enough to show it, but it is tiny. Like, it's teeny, 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 tiny. So we're going down, and the Alvin is, stop by the open space booth later, and I'll show you. The Alvin's like right there. It gives you this immense sense of scale of what is under the water, and it's just so cool, and I'm so thrilled with how this is turning out, and it is something that I actually want to share. Last year, I didn't really want to share my program with you all, because I was like, I don't think it looks that good. So I'm really, really, really excited how this is turning out. And then part of my grant was also to win money to go with the Jet Propulsion Laboratory and take this out with them. So I am partnering with JPL to do what we're calling the Ocean Worlds Roadshow, and that will be happening within the next couple of months. And then I'm also making this my PhD. So that was not expected at all. So that is what I'm going to be doing, is connecting this ocean and space research with open space to study the efficacy of using the narrative paradigm. But really the ultimate thing, and I know I'm at the 10-minute mark, is I live in Rockford, Illinois. We have some of the highest crime rates per capita in the United States. And the schools that I take my portable dome shows now to are so appreciative because they can't take kids on field trips. It's too much of a liability to take them out. And I have become immensely in high demand because of this reason, and it is honestly like something that has completely changed my life, and I've had well over 5,000 students in my dome in just less than a 2-year time. And it's been something I never would have thought that this would be like my life and my work, but yeah, it's been definitely my calling. Thank you.
Can you comment on the mapping technology that is used?
I will have to, I can talk to you later about it. It's the company is called Almost Human Media, and he does lots of like VR kind of stuff. So I'm not really sure what tool, I don't know what software he used. I just know it looks good. And I hope you learned a little bit about science today too.
All right, if there are no more questions, thank you, Sarah. All right, folks, up next we've got Ron Proctor with Open Dome Sharing Full Dome Resources from NSF NORLab.
Thank you very much. Yeah, I'm Ron Proctor with NSF NORLab, also with NSF Kitt Peak National Observatory, which is your national observatory. NSF NORLab operates Kitt Peak National Observatory and also observatories around the world, including Rubin Observatory. We also operate the Gemini International Observatory in Hawaii and also in Chile, and others. Our mission is to enable and share breakthrough discoveries in astronomy and astrophysics with state-of-the-art ground-based observatories, data products, and services for our community. And so how do we do that? Part of my job is the sharing part. We think of the dome as the bridge between research and the public. And it's not just the bridge between the sky and the research, right? Because we have domes, as you can see. But y'all have domes as well. And the dome is that bridge. And we want to get information from our domes into your domes. And we want to make that as accessible as possible for y'all. The other main point is that time domain astronomy is advancing, and audiences are getting really curious about that with the advent of Rubin Observatory, and what it's about to do is going to be really breathtaking. Rubin is currently in its last engineering shutdown for its final construction phase, and it's about to begin its regular operations literally within days. And when that starts happening, Rubin is going to make essentially a movie of the sky. Every few nights, it will image the sky that it can see in huge detail and in breathtaking resolution. I've been able to work with some of the raw data from Rubin, and it's bonkers. So I can't wait for the pipeline to start flowing, and for the public to start getting all that stuff from Rubin. But in the meantime, the purpose of this presentation is to give you guys links to dome-ready shows and clips, and also spark ideas for community use. So that link is norlab.edu. This is the way to get stuff from us. Our website is the conduit. And so if you haven't seen it before, I'll just give you a quick idea of what that looks like. You visit norlab.edu, and there is a little menu here up at the top on the bar. If you're visiting on a phone, you'll see a little hamburger menu where it'll say open menu, and you'll click on that or tap that to go into this little gray bar at the top there. And you can click on images, go to categories, and we have a full dome category. And you'll find hundreds of full dome images. We also have hundreds of 360 images. You can also go to videos, full dome, and find hundreds of full dome clips. Literally hundreds that you can download and use for free in your dome. I want to highlight a few of these. Some of these are shows. We have 3 shows that you can download for free and use. So the first one is Messengers of Time and Space. It's our most recent show. And I was the producer for that show. It's a 4K show from NORLab. We're talking about the dynamic universe. We're talking about time domain astronomy in this show. It talks about how Rubin will generate alerts and how the Gemini Observatory will follow up on those alerts, and it introduces audiences to those concepts. We also have Big Astronomy. which explores Chile's world-class observatories. It celebrates the people behind the science. And it's built with accessibility in mind. So it includes resources for people who are deaf or hard of hearing, also people who are blind or low vision. We also have One Sky, which is a collection of 7 shorts, and this explores different cultural and traditional views of the sky. Also very flexible, so you can show just a module if you'd like, or you can show the whole thing. All of these are free. And then, of course, as I mentioned earlier, the short form media archive, we have hundreds of full dome clips and images. All of these are available under the Creative Commons Attribution License. So just like you see on my screen here, I've put like a quick little credit line. That's all we require. If you use our stuff, you'll see on the website, it'll have like a quick little like Rubin Observatory, NORLAB//slack/NSF/DOE/aura/T Matsoupalis in this case. That's all the credit we need. That's all you got to do. You don't need to email us. You don't need to pay anybody. Just throw that credit in to the credits and you're good. We're covering observatories, cosmic visuals, sky sequences, and it's flexible. And you can combine your own live narration. You can do all kinds of crazy stuff. So, looking ahead, they brought me on to actually make planetarium content, and so I'm doing that. We're making new short segments and data-driven visualizations. We have some, I'm really excited about the next point. We have some 4Pi all-sky multi-wavelength maps, which are a dozen plus multi-wavelength maps that map the entire sky that we'll use to make multi-spectrum journeys throughout the whole sky that will convert into full dome clips. Possibly we could make a show out of that. I'm not sure if we'll get to that point anytime soon, but your feedback will affect what we do. Open access keeps your domes updated with the latest discoveries, and I'd like to invite you guys to co-create. I'm looking for your feedback on themes, on data sets and formats that are going to work for you. So currently we're offering full dome. We offer 360, which is equirectangular. And thank you. And those are our main formats. So kind of in closing, to wrap it up, check out norlab.edu. You're going to get the video and image archives. You get free dome-ready clips and stills under Creative Commons, tools for educators, including feature shows, short clips, stills. We have some 3D models there, and it's built for collaboration. So we'd love for you to adapt, remix, and give feedback so that we can serve you better. So with that, I have questions for you. What can I do next? What can we do to serve you better at NORLAB?
Hey, Ron. I think my public is struggling to understand the idea of why this is a different kind of telescope. You said breathtaking. This is going to be doing breathtaking work, and we've had breathtaking work from other telescopes. So I guess a nice pipeline to my audience would be, Vera Rubin is different, and here's why. And in like 5 minutes flat. That would be awesome.
Okay. Great one. I'm taking notes. So why is Rubin breathtaking in 5 minutes? Well, okay.
I do know that Rubin is producing some educational modules and stuff, but with these that you're producing with the NORLAB, and the clips or the actual, in particular, the shows, are you producing educational materials and connections with standards and things that'll impact admin and make impression on them that we're making all of these strong connections with these standards?
Yes, thank you for asking that. And I neglected to include that in my presentation. We do also include educational materials, and our education department is producing those. Those can also be found on the website. Thanks for asking that. I appreciate you.
One question I had was with the imagery and the animations that you present, is there an option where you also have like a second copy that would have the actual name of like the Vera Rubin Observatory, just the name to highlight what they're seeing? Because sometimes in my presentations I have kids that are very distracted, or they can't, you know, they're trying to listen in, maybe their friend's talking to them and they want to know what's the next thing up on the screen that they're looking at. So when the presenter is talking, they might have not caught what the presenter said. So even just like a little, like I guess a copy of it with like wording, just to say what it is. Oh, this is the Vera Rubin Observatory, to pop up as a suggestion, or is there something that you guys are looking at that could address that?
Okay, let's talk a little bit more about that. I want to make sure I understand what you want to do. So like kind of subtitles, or like kind of a burn-in?
Yes.
Okay.
As a separate, so you have the option.
Subtitles to describe the next.
Like what you're seeing, because sometimes, you know, people are talking to someone who's trying to watch, right?
So with and without the logo?
Yeah, you have two options, right? So they can just have.
Yes, sir.
Hi, Ron.
Hi, Mike.
Hey, so one of the things that we found really useful with the very first images that were released, particularly the lagoon and the trifid, we used a common observatory view of what those things look like, registered to what the new view would look like, so we could do a crossfade, and that helped to reinforce, why is this so different? Why is this so special? Why is this so spectacular? When people can actually see it and compare it to what we used to see, then you get the awe factor, the wow factor.
I
So
like
is
that.
that something you guys would be able to provide?
We certainly can, and I think also to compare the just the field of view in the survey versus what you can get with a typical telescope is also very illustrative. So.
Thanks, Ron. Just had an idea too. One shot and done would be nice for the why is it breathtaking, but maintenance continued. Like download another show, public shows. Hey guys, guess what's new at the Vera? I'm going to show you guys from Ron. This is what Ron's telling us about the Rubin this week. Next month, I get the same audience. Hey, this is what Ron's telling us about new discoveries at the Rubin this month. You know, like monthly quick subscription or something we could download and just show our audiences, this is new, what's happened at Rubin every month or something. That'd be really cool.
Monthly updates from Rubin.
One last one while Ken sets up.
Thank you all very much.
Yeah, if you wouldn't mind unplugging yours.
Yeah,
so
will
Ken
do.
can- yeah. One more.
So a show idea would be, for me, a lot of groups, so a lot of planetariums that I'm talking to, they do 5th grade content. And one thing for that is distances, like stellar distances. So I know Vera is very good at doing like asteroids and things that are close, but it might be a good idea to develop that whole idea all the way through of how do we get distances to stars, something that Rubin's really good at. And you know.
Okay, so how do we reckon those distances?
Yeah, and how do we do that like all the way through in a complete thought, you know?
Awesome.
So
Okay.
something near, something far, just a show idea.
Thank you very much. Okay, and I will keep on adding to this list. Please continue to come to me, and let's keep building this out. And thank you all very much.
All right, up next we have Ken Murphy, and he's going to be talking about ground-based night sky astronomy in open space.
All right, hello everyone. Thanks for coming to my talk. My name's Ken Murphy. I'm from 2.5 hours from here, and boy, does it feel good to say that. I'm used to saying 10 hours away from here. So anyway, I am an open space user. I've been using it for about 5 years, and prior to that I was using UniView, which is similar. And I really enjoy open space. I enjoy the price tag. But also, it's very powerful, and I hope you give it a try. Even if you're using some other system, you have nothing to lose to try it out. Open space is really, really good at globe browsing, hopping from planets and setting down and looking at layer sets and so on. And it's also very good at interstellar and intergalactic data sets to demonstrate. Maybe less good at ground-based astronomy, where it's feet on the ground, do a little constellation show. And so it's actually improving quite rapidly. But I've added some things to make it even easier yet. In fact, my plan then with it is to make it as much like Stellarium as possible. And I really like the way Stellarium operates so easily and quickly. So that's what I'm all about with my talk today. So smooth transitioning from globe browsing to ground-based night sky is a high priority for me, just for my audiences, so we can, what's going on the ground and then what's going on in space, and we can fly back and forth. I'm very much into live interactive programming, so I really enjoy open space for the fact that I can just fly anywhere and react to my audience on demand. So again, I used to use Stellarium, Nightshade, the old legacy version of Nightshade, to do ground-based stuff. But today, I'm exclusively using open space. I also love my optical mechanical. I said exclusively, I still use this, but not so much in outreach, but more in my classes at various times. So I also want to incorporate some of the features of an optical mechanical projector into open space. So that was a goal as well in what I've developed. In open space, we use these things called assets, which really give open space more features than it normally has. So you'll hear the word assets all the time. And I use 3 or 4 of them quite regularly. And I have to do a shout out to Dan Tell, James Hedberg, and Micah Akinapura for developing these assets. And I've bundled all this together, so if you want to use these things, get a hold of me. I'll have my email address up at the end, or you can search me out, and I'd be happy to share these things. So I'm going to fly through these slides so I can actually get into open space as quickly as possible. But transitioning from backyard to globe browsing and beyond is something I like to do smoothly on the fly. Constellations, rapidly pulling them up to do a night sky talk. I've developed some things there. Again, a lot of shortcuts like Stellarium uses. I've also developed an ecliptic. I made that in Blender, pulled it into open space so that it looks more like in a planetarium dome. And you're welcome to the Blender files if you want to tweak it for yourself. And it's also in the newest release of open space, so you don't even have to ask me for that. Also I do some tweaking of the planets, the moon. Sometimes we like to exaggerate our moon so we can see it better, see the detail on the moon. Even though it's artificial, it's kind of nice to have a scaled up moon, scale up the sun a little bit, and tweak the planets to look their best in your dome. So let's move ahead. Time control, big time important. Open space uses the number keys at the top of the keyboard to adjust your time flow rate. And I find that 1, 5, and 6 are really what works best in doing night sky. Oh, sorry about that. All right. Also, I have a HUD display that lets you track what the local time is, the simulation time, up on the dome for the audience to see. We jump by sidereal days, solar days, just like Stellarium. We use the comma, if you're familiar, the comma, period, and semicolon for your ecliptic and all of that good stuff. So, yeah, if you're a Stellarium user, you should be able to fall right into it. Here's my email address. I'll try to remember to pop that up at the end if you want to catch it then. But next, I would like to pull up open space, do a little flying for you. So here we go. Can you see that okay? This is what you get when you start up open space. And what I have, we have the GUI and the display both, yeah, thank you. The GUI and the display are kind of superimposed. You can do it all different ways in your home system if you want to separate those to different monitors. But here's what you get when you go into fisheye mode. And you can see we are focused on the Earth, and I like to get rid of the planet trails. And so T for trails is our shortcut for that. And let's zoom in to Earth, and we'll set down on the ground. So I like to do a little fade, and then presto, there we are on the ground in our backyard. And you can see the looks kind of stellarium-like. It's a familiar view on a lot of our systems. Time control, again, that was the 156 key in open space, so we're going to speed up our clock. Also, I should mention that over the summer, the open space team came out with a new release, and it is a total upgrade of the interface. The user interface has gotten a lot better and a lot more customizable. Okay, so here are our stars. Now we're looking at our night sky. We can start our sky talk. We can start pulling things up rapidly here. Let's do just pull up a couple things. Oh my gosh, wasn't expecting that. Let's set back down. I'm getting in a hurry here. Summer triangle. You can see how fast I can pull these up. Let's, yeah, there we go. Yeah, I got to change the time. I'm going to fade out the blue sky. Same thing as stellarium. I just hit the A key for atmosphere. But let's speed up there. We'll get the sun down. Let's do Cygnus. We'll get an image. Let's get the dippers up there. So you can go ahead and do your star talk. Turn on some things. We got some asterisms. And then when you're all done, you can just wipe it out and go on to something else. Here's the ecliptic that I made in Blender. So we can do all kinds of neat stuff. We can bring out the planets. And so again, I've tweaked these for my dome. I don't know how well you can see that. We've got labels. Okay, thank you. We got our labels and time control. So if I hit the plus minus keys, just like in stellarium, we can control what we call annual motion. And so this is how I control annual motion, just like in a star projector, back and forth. If I hold the shift key and do the same thing, I can advance by solar days, and then we can do things like demonstrate the analemma. I'm doing it very fast. I can do it slower. But anyway, so you can do all your favorite ground-based things now in open space. So let me finish this with taking off and heading back into space. So kind of resetting our everything, and let's kind of flip our view down, our camera view down, get rid of that ground panorama. We can restore our blue sky here, and we can launch. We're launching from my hometown of Marshall. And then off we go back into space, and you can start your globe browsing. So that's the end of my talk. Thank you. I'll bring up that slide if you want to catch my email address and contact me for any of these materials. I'll be happy to share and help you out. So thank you very much.
Any questions? Raise your hand if you have a question. Oh, wait for the mic. Wait for the mic.
After the at, what are those letters?
Oh, yeah, let me just spell that out. It's kind of a dark color there. It's ken.murphy@smsu.edu.
Does open space go out of the solar system?
Oh, yeah, yeah. You can leave the solar system. That's really what it, like I said in the beginning, that's like what it's best at, is to go out and travel through the stars. You can go outside of the Milky Way, through the galactic data sets like the Tully, the Sloan Digital Sky Survey. It's got the entire digital universe embedded in open space
And
for free.
How often is it updated for the?
That's a good question. The curators of open space are at AMNH, and so they make all their data available to all the other systems, so everybody's using and pulling from the same database. So it gets updated periodically. Depends on what it is. Some of the things in open space update pretty quickly. Other things, it happens in later time intervals. So.
And Ken mentioned this too, but it's all open source and free as well.
Yeah, so actually the web address, if you want to go and download it, it's openspaceproject.com. What's that?
Oh yes, and Open Space has a booth.
Yep. All right, yes, and I'll be in the open space booth and along with a few others, so please stop by and we'll give you a full demonstration. You'll really want to see the new GUI interface. It is really tremendous. What a big improvement. Thanks, Ken. Okay, thank you. Oops.
Alrighty, our last speaker before another break here is going to be Eric Johnson, and he's going to be talking about facts, inferences, and speculations about the Nebra Sky Disk.
All right. Hi, folks. I ended up seeing this in person last summer after the IPS conference, and I was so captivated by it, I felt like I should share this with the public. I guess, you can see that I'm wearing slightly less ostentatious clothing right now. It was because I'm wearing a shirt from the museum that we saw it in, so I guess it was the been there, done that, got the t-shirt type deal. But I just wanted to share all of this with you. Many of you probably are aware of the Nebra sky disk, and I wanted to see what I could read about it and convey during this talk. This is my terrible photo of the sky disk itself compared to the much more professional image on the last one. You are looking at an artifact that is made mostly out of bronze. You can see the patina on there, and then all of those features that you see on there that look like things that you can identify, some arcs, the crescent, and what might be a sun or a moon, or maybe an eclipsed moon, I don't know, or an eclipsed sun. All that is actually made of gold. It is just over 1 foot in diameter. You see about 32 centimeters, and it weighs roughly 5 pounds, about 2.2 kilograms. Okay? And the reason why many of us may not be aware of this is because it's a recent discovery. This thing was actually found back in 1999. And, you look at this thing and you are kind of surprised about it and what connections it could be making, because it's rather unlike other artifacts that have been found. Unfortunately, the initial investigations of this were not undertaken because it was not found by professional archaeologists. It was found by looters. It was found by treasure hunters who went and immediately sold this thing right after they had found it. I think for about like 30,000 Deutschmarks at the time. And it changed hands several times after that. And eventually, they were able to recover it through a sting operation in Switzerland about 3 years later, and it was finally returned to that State Museum of Prehistory that's located there. And I believe that was in, I forgot the name of the state. But it was located in Germany. The fact is, digging up archaeological artifacts and other information like that that material is the property of the state. So it was meant to be returned to that state there. So the place this is located in is Halle, and Zala right there is written in parentheses because of the river that it's on. One thing that I failed to mention at the beginning of this slide, you are seeing some swords. Those were some swords that were found next to it. It was also found actually with some ringlets that would go around the arms. It was also found with some remains of axes. The axe heads were still intact, but the handles had decomposed over time. It was based off of that sort of information that they were actually able to make some decent estimates about the age of this creation. Okay? The fact is, the sky disk here, it's very difficult to actually get a proper age because you can't do that sort of aging estimations on bronze and gold. They had to use these other finds from this whole hoard in order to get those age estimates. Overall, they have found that the disk probably goes back about 3,600 years, okay, which is just amazing, unimaginable to think that such an astronomical artifact was produced so long ago. Apologies there, it's supposed to say sun, moon, and stars. Notice that the image right here, this reproduced image, is showing you a little bit less than what you saw on the regular disk. What archaeologists had determined rather quickly was that the disk had to be made in multiple stages or phases. This is what they imagine the original phase should look like. You do see that what might be a sun, you see that crescent moon, and you do see about 32 stars in there, okay? Now the funny thing is though, you see about 7 of those stars are clustered together. Well, the thing is, those were probably the Pleiades, okay? The Pleiades has been seen by people in the sky for thousands of years. We have records going back such a long time, and even to the present day, we have people who are not certain what they're usually looking at, and oftentimes it's just the Pleiades. So much so that there is a subreddit for it always being photographs of the Pleiades, hence why I was sharing that with you all. This is phase 2 right here. You can see some slight adjustments that were made. We are seeing arcs on the left and right side of the image. A couple of the stars have been superposed, and one was even moved. This has been estimated to be based off of the range of sunrises and sunsets at this latitude in the world. The site Nebra is roughly about 51, 52 degrees north latitude, and up there it is a roughly 82-degree range between sunrise and sunset. Many of us, probably all of us, are very aware of the sorts of sunrise and sunset positions that are depicted at Stonehenge, at other archaeological sites that we see going back a long period of time. And it appears that those arcs, which match it quite precisely, seem to also be present upon this disk. Okay? Now, that third arc, the one down at the bottom there, you'll notice that it's not running right along the circumference. This one is subject to a little bit more speculation. It has been thought that this is representing a solar boat. In many cultures in Europe, in Egypt, and around those parts of the world, there were cultures that had mythology of the sun being carried across the sky in one vessel or another. So the archaeologists believe that this is an abstract representation of that boat carrying the sun across. It's entirely possible, but it's hard to get this exactly verified. But there's just people looking at these solar boats across various cultures and seeing how far back they go. So as you can see, I'm hedging my bets on a lot of this, just like how they are, but this seems to be the leading hypothesis for what that boat is happening to do. Now, there is one final major mystery that you can see on this. If you look closely back at the earlier slides, I'll get you an image of the sky disk here. 1 second, sorry about that. There we go. You can see the little holes along the edge of the disk. There's roughly about 38 to 40 of them. We're not sure of the exact amount. You can notice on the upper left there's some significant damage that was done to the disk. Those treasure hunters that were working on this disk at that time, there's significant evidence showing that they damaged the disk upon digging it up. They were not exactly, what would be the word? They were not great respecters of the land. They weren't very diligent with how they were trying to preserve the site for future studies. So the problem is, those 38 to 40 holes, we have no idea about what their purpose was. Maybe it was meant to just be hung as like some sort of shield on some person's garb. We have no idea. Maybe it was meant to be held at certain angles. Thank you. All right. At the museum, they had commissioned an artist to do this painting, signifying many of the representations on the disc. I thought that was very cute, so I wanted to share that with all of you right there. But, it seems to be just based off those leading archaeological theories right there. Additional rules that we could see upon this disc, the exact role of it, it could be based off of keeping certain calendars. One interesting idea about the disc is that, I thought there would be more images. That's right. It was going to be Robert Downey Jr. Okay. The fact is, you saw that the crescent moon was next to the Pleiades. It is thought that it's meant to represent how the Pleiades lines up with that crescent moon about roughly once every 3 years. And every 3 years is around the time when we would have enough of a misalignment between a lunar calendar and a solar calendar that we would have to add a leap month. We still see this in the present day with the Jewish calendar, as a matter of fact, okay? Because the lunar calendar is about 11 days off, all right? So that has been hypothesized as one reason for why the Pleiades is being depicted on there. If so, that's a really sophisticated use of astronomical timekeeping. The other possibility, and this one's much more speculative, is the 32 stars for 32 years. It so happens that 32 solar years is almost exactly equal to 33 lunar years. Maybe they chose 32 for that reason. But again, that's something that we cannot state exactly for certain. Okay? Fascinatingly, when I was looking this stuff up initially on this website, I went to the place that all of us go when we do our initial investigations, Wikipedia, and there were some things posted in the gallery at the end of this entry where somebody had shown their own hypotheses. These have not been vetted by anybody, and it looked like the person who made these hypotheses posted them themselves. They are, I think, a lot more speculative, even more so than the things that I've already shared with you. I do not find these valid necessarily. So therefore, I decided to share with you folks a few other fun gifts for all of this. This one is actually trying to speculate that the path of Vega on the winter solstice is meant to represent that solar boat. Unfortunately, though, if you look really closely at my screen cap, that says 2026. A lot of you folks know about precession, and you know that Vega is going to behave a little bit differently 3,500 years ago. Okay? So I think they made some basic overlookings of stuff. So, yeah. Anyways, folks, I want to thank you, and I also want to share with you that we had a great time going and seeing this stuff and seeing the planetarium show at near the dig site right there. So I think I'll leave it at that slide. Thank you so much.
Any questions? No? All right. Thanks, y'all. So that's the last session, and lunch is going to be in 5 minutes.
Thank you, Mary. And y'all can go buy your own replica if you want.